Well, hey guys. In the previous video, we talked about easy elimination or previous notes, but in this video, we're going to talk about next level elimination. Now, in those previous notes, we had some steps for elimination that look something like this. Now, if you want to copy it down, go ahead and press pause and copy it down or pull out your notes from before. And we're just going to add, today we're going to talk about the first two steps. The first one is align like terms. Let's do it. Let's give you an example so you know what I'm talking about here. Let's talk about our first example is going to be 2x plus 3y is equal to 1. And then we have 4x plus 5y is equal to 3. Now, just like yesterday, step 1 is good. The terms are aligned. Look at this. X on top of x, y on top of y, equal on top of equals, and constant on top of constant. So the terms are all aligned. But the problem is, yesterday, if we were to add this up, don't write this down, but if we were to add this up, this would be 6x plus 8y is equal to 4. Did anything eliminate? No. And that's the whole point of this lesson, is to eliminate things. And so that brings us to step 2. Step 2 is multiply to get one set of opposite coefficients. Multiply to get one set of opposite coefficients. So what I mean by that is the coefficient is the number that's being multiplied by a variable. And opposite means they're the same number except one is positive and one is negative. So here x has a coefficient of 2 and 4. Y has a coefficient of 3 and 5. We need to get them to be the same, and we're going to multiply. The easiest way to do this is to multiply the top one. We want 2 to be 4, except opposite, negative 4. So we're going to multiply the entire top equation by negative 2. We're going to multiply lottie-dottie, body by negative 2. So it's going to be negative 4x plus, excuse me, I made a mistake. Negative 4x minus 6y equals negative 2. See how everything is being multiplied by negative 2. All three of those terms. The bottom one, we're going to keep the same. 4x plus 5y equals 3. Now you might be able to see step 3, when we add the equations, something is indeed going to eliminate. Check this out. The x's cancel. We're left with negative 6y plus 5y is negative y is equal to positive 1. But we don't care about no negative y. We want to know what y is. So, a couple ways to do that. You could divide by negative 1. You could multiply both sides by negative 1. Or, if the opposite of y is equal to 1, then the opposite, y, is equal to negative 1. So now we got y. We eliminated it. We solved for the remaining variable. We got y is equal to 1. Step 5, plug into an original equation and find the eliminated variable. We eliminated x. We know y. We have to find x. So I'm going to choose, which one you want to do, the top one or the bottom one. I'm going to use the top one because they're smaller numbers. So that's going to be 2x plus 3. But y is going to be something else. Is equal to 1. What's going in for y? Well, the negative 1 that we found. So, we have 2x minus 3 is equal to 1. Keep solving. You get 2x is equal to 4. X is 2. Alright, so now we got x, now we have y. Our final answer is an ordered pair. Our ordered pair is the number 2, or excuse me, the ordered pair is this point 2, negative 1. There's our solution. So we're just adding an extra step here. It's just like yesterday, it's just now we're going to have to multiply to ensure that we have opposite coefficients. Let's do another one. Example 2. Example 2 is going to be 3a plus 5b is equal to -1. Sorry, I'm going to move this down a bit, give myself a little bit more room. Is equal to -1. And then we have -4a plus 2b is equal to -16. All right, so once again, everything's aligned. A's on top of A's, operation on top of operations, B's equals constants. But if I add this up, will anything eliminate? No. So we're going to have to do step 2 and multiply to get something to eliminate here. Now, we can work with 3 and 4 and try and get the least common multiple between those two numbers, or 5 and 2. I'm going to go with 3 and 4 because one's positive and one's negative. Less work to do, right? We need same number but opposite. This one we would have to multiply by a negative if we were trying to get b by itself. So 3 and 4, what is a common multiple they both have? Well, they can each get up to 12, right? So I'm going to multiply the top equation by 4, and I'm going to multiply the bottom equation by 3. Top's going to give me positive 12, bottom's going to give me negative 12, and then something will eliminate. So we have 12a plus 20b is equal to -4. Remember, lottie-dottie, body. We got -12a plus 6b is equal to negative, what's 16 times 3? 48. All right, so add these up. When I add these up, check it out. The a's cancel. We have 26b is equal to -52. We're going to divide by 26 on both sides. B is equal to, if you need your calculator, go ahead. But, spoiler alert, B is -2. All right, then go back to the original. Should we use the top equation or the bottom equation? Again, it doesn't matter. However, I think I'm less likely to make a mistake without having to deal with that negative. So again, I'm going to use the top equation here. 3a plus 5 times something is equal to -1. What's going in for b? -2. So, keep solving. 3a minus 10 is equal to -1. Add 10 to both sides. 3a is equal to 9. A is 3. And then we write our final answer as an ordered pair. 3, -2. Step 7, check. Plug them back in. Make sure they both work. In this case, they both work. One more example for you here. One more example for you here. I'm going to go to the back page. 3j plus 5k is equal to 19. And then we have 4j equals 8k minus 4. Now this particular one, is this stacked up correctly? I got j on top of j, but then it's operation on top of equals. K's on the other side on the bottom. It's on the left side up top. It's on the right side on the bottom. Operation. This is a mess, right? So check this out. Let's get this into like a pseudo standard form. It doesn't have to be leading coefficient positive and stuff, but so let's get the k on the bottom on this side. So the bottom equation, if we were to subtract 8k from both sides of the equal sign, the bottom equation is going to become 4j minus 8k equals -4 remains on the right side. The top's going to stay the same. You got 3j plus 5k is equal to 19. But now if we add them up, Will things eliminate? No, so that brings us to step 2. We got to multiply to get a common coefficient. We could do the j's again. We could multiply the top by positive 4 and the bottom by negative 3. Or vice versa, top by negative 4, bottom by negative 3. But here's the thing, k is already positive and negative, so I'm going to go with that. So I'm going to go ahead and eliminate the k's in this case. So what is the least common multiple between 5 and 8? It would be 40, right? So I'm going to multiply the top by 8 and the bottom by 5. And we're going to have 24j plus 40k is equal to, you might want a calculator for this. I'll tell you what, keeps moving on me. How about this? What is 19 times 8? 152. Got some big stuff here. Then the bottom, we're going to multiply lottie-dottie everybody by 5, so it's going to be 20j minus 40k is equal to negative 20. All right, so then we're going to add this up. Excuse me, we get 44j. The k's cancel in this case. Equals 132. I'm going to divide by 44 on both sides. Man, I don't know. It's 132 divided by 44. Tree. Hey, that worked out nice. J is equal to 3. Great. J is 3. So what? Now I got to find K. So I'm going to go back to one of these. Does it matter which? No. I'm going to pick the bottom one this time. Here I have 4 times J is equal to 8K minus 4. We know what J is. J is 3. So actually, yeah, I'm going to do this. How about that? J is 3. And we're going to have 12 is equal to 8K minus 4. Add 4 to this side. You get 16 is equal to 8K. What is K? K is 2. So your final answer, remember in alphabetical order, H-I-J-K. So our final answer is going to be 3, 2 as an ordered pair. That's what's up. Align them. Multiply so that one of the coefficients are opposites. Add them up. Solve. Plug it back in to one of the original equations. Find the other variable. Your final answer is an ordered pair. Bring your question to class. Smith out!